discuss about some more topic which are based on decimal number, which are based on decimal number. Decimal number. In this chapter, we have already discussed about what is the decimal number and how we find their place value. Okay. Today we shall discuss about the representation of decimal number on the number line. So our first topic is representation of decimal number on the number line. On the number line. As we know that the decimal number having two parts. The decimal number having two parts. If I write a decimal number 2.5, then in this number we can see that it has two parts. 2, which is the whole part, and 5, which is the decimal part. Which is the decimal part or fractional part. Okay, so that a decimal number has two parts. The first is whole part and second is the decimal part. Whenever we represent the decimal number on the number line, our first step is we have to compare that number. Okay. Comparison give the idea between what two number the decimal number will vary. So that first of all we compare the decimal number. But here one most important thing I would like to tell you that whenever we compare the decimal number, we compare the decimal number with the whole number. Never we compare the decimal number with another decimal number. Okay. If we do like that, then our solution or our conclusion may be wrong. That is why every time we compare the decimal number with whole number. If suppose that 2.5 is a decimal number, then if we compare this, then we find that 2.5 is greater than 2. 2.5 is greater than 2. And here we will not write 2.5 is greater than 2.6. If we do like that, then our calculation may be wrong. That is why here we can see that the number 2.5 is less than 3. Okay. So here we conclude that 2.5 will lie between 2 and 3. Okay. So we draw the number line and we represent 2.5, which will lie between the point 2 and 3. Therefore, the comparison is done with the whole number. We never compare the decimal number with another decimal number. Okay. So now let us see where 2.5 will lie on the decimal number. This is the number line. This is the number line, and we know that on the number line, this number line consists all type of number. That is, it consists natural number, whole number, integers as well as rational number. That is, you can say that fraction. Okay. Whenever it consists fraction, then it is obvious that it also possesses decimal number. So here we start it from 0, 1, 2, 3. Okay. So here we have the number line on which I just denote 1, 2, 3, 4, and it may increase for the both direction. But here I just take 3 point because here our required number 2.5 is lying between 2 and 3. That is why we didn't get more number. So here we can see that 2.5 is greater than 2, which means that 2.5 will lie on the right side of 2. Why? Because as we know that on the number line, on moving left to right, number increases continuously. The numbers increases continuously. I am not telling you that the decimal number increases continuously. I just say numbers increasing continuously. Here you can see that it is 0, 1, 2, 3 and 4. Here you can see that the numbers are increasing continuously. Therefore, 2.5 is greater than 2, which means that 2.5 will lie on the right side of 2. So, it is clear that 2.5 will lie on the right side of 2. But here, 2.5 is less than 3, which means that 2.5 will lie on the left side of 3. That means 2.5 will vary from 2 to 3. Okay, which means that 2.5 will lie between 2 and 3. So here in 2.5, 2 is the whole part. 2 is the whole part, which means that this will represent 2. This point represents 2, but here also 0.5. So what is the meaning of 0.5? The meaning of 0.5 is 5 upon 10. So 5 upon 10 says that here we have taken 5 parts out of 10, which means that first of all we shall divide the part between 2 and 3 into 10 equal parts. Okay, so here we divided the space between 2 and 3 into 10 equal parts. Now this represents 2 and 0.5, so count from there 0, 1, 2, 3, 4 and 5. So that the point this P, the point P will represent the decimal number 2.5. Okay, so that the point P will represent the decimal number 2.5. Okay student, I hope it is clear to everyone. Okay, now let us see the next topic, which is the like fraction and unlike fraction. Like decimal number and unlike decimal number. As we have studied in the chapter of fraction, where we have defined like fraction and unlike fraction. Whenever we study the like fraction, we say that the fractions having the same denominator known as like fraction. Here the concept is same on the decimal number. Here we know that the decimal number are actually the decimal fraction. So that if I write some examples here, so So see carefully. If I write 5 upon 10, 17 upon 10, 29 upon 10, 375 upon 10. Okay. So here we can see that this is the decimal fraction. These are the decimal fraction. Okay. And one most important thing, you can see that the denominator of all the fractions are same, and that is 10. Okay. The denominator of all the fractions are same, that is 10. So that this can also be written as 0.5, 1.7, 2.9 and 37.5. In the hour, we can see that all the denominators are same. That is why it is known as like decimal fraction. In this section, we can see that the number of digits on the right side of decimal are also same. The number of digits on the right side of decimal are same, so that the number of digits is 1 in all the decimal number. Therefore, it is known as like decimal number. Therefore, they are the like decimal number. Okay, so they are known as the like decimal number. So whenever if I ask what is the like decimal number, then your answer will be the numbers in which the number of digits on the right side of decimal are same, known as like decimal number. They are known as like decimal number. Now the next is unlike decimal number. In the fraction we have already studied unlike fraction. We say that the fractions having different denominator are known as unlike fraction. Okay. So similarly here we can say that the decimal number having different number of digits on the right side of decimal number are known as decimal number, unlike decimal number. Okay, so here we can say that 0.6, 9.25, 0.378 and 4.92, etc. So here you can see that in all the decimal number, the number of digits on the right side of decimal are different. Therefore, they are known as unlike decimal number. Okay, students, I hope it is clear to all. So this is the some important topic which are necessary for our further education. So I suggest to all students, please keep it in the mind and still remember. It may be also asked in your examination as usual definition. Okay, so these are the topics which we have to discuss. Okay, now here one more important thing, that is the comparison of the decimal number. As we have studied the comparison of fraction in the chapter of fraction, similarly here we shall discuss about the comparison of decimal number in this section. So let us see what is the comparison of decimal number. I write 1.75 rupees. If I write 1.75 rupees and here I write 0.98, then if I ask which one is greater, then you will say that this 1.75 is greater than 0.98. Why? Because here we can see that the whole part of the first decimal number, the whole part of the first decimal number, that is 1. The whole part of first decimal number, that is 1, is greater than the whole part of the second decimal number, that is 0. That is why this decimal number 1.75 is greater than 0.98. Okay, so this is the comparison. We shall also discuss more about the comparison on the decimal number in my next session. So keep watching my video. Till then, goodbye.